tremendous love of plants, a tremendous desire to learn about plants and learn the names of plants, walk around in the woods and just look at plants. And so that really is what became the focus of my career. And so for the last 40 years, I've been studying plant ecology, and I'm a professor at Boston University. A lot of my career was actually spent studying tropical rainforests on the island of Borneo in the country of Malaysia. And then around the year 2000, I decided to completely change the focus of my research. And instead of studying plant ecology and tropical ecology, I decided to shift over to study climate change. And part of the reason was also that I was also writing textbooks in the field of conservation biology. And as I was working on the latest edition of my book on conservation biology in 2002, I realized that I didn't have any good examples of the effects of climate change from anywhere in New England, that all the examples of climate change were from faraway places. So for example, like polar bears in Canada or wildflowers in the Swiss Alps. And so starting about 19 years ago, I decided to completely change my research from looking at tropical rainforests to looking at the effects of climate change on the plants and animals of Massachusetts. And at that time, there were no good examples of climate change from anywhere in the eastern United States. Again, all the examples were from faraway places. And now after 19 years, the metropolitan Boston area is probably the most well-studied area in terms of climate change of any place in the United States because of the work that I've done with my students and many colleagues from the Boston area. And what I'm going to mention today to you is that there's also a very good possibility for doing this kind of research in Falmouth or on Cape Cod. So for those of you who are interested in the environment or climate change, I would suggest that this is actually a very good opportunity for you to actually start making observations yourself. So first of all, climate change. So I think this is something that you probably learned about in your science courses or read about or watched TV programs about. And you probably all know that the world's climate is changing and that Boston and New England have already been very strongly affected by climate change. And climate change refers generally to the warming of the atmosphere, to the warming of the air. And so it refers to an increase in temperature, but it also refers to other changes in the climate as well. So for example, changing patterns of rainfall. And as the climate warms and as the polar ice caps melt, as glaciers melt, the sea level is also rising. So this is part of climate change, which would very strongly affect you here in Falmouth, and also rising levels of carbon dioxide. So all these are all part of climate change. And in the New England area, we actually have the best weather records of any place in the United States. So the Blue Hills Observatory is the longest running observatory in the United States. And this is a figure showing how the temperatures have changed at the Blue Hills Observatory over the last 200 years. And you can see that temperatures in New England are extremely variable. You all know this, but the long-term trend is toward a warmer temperature. And you can see that we've had about a 3 °F increase in temperature, or about 1.5 degrees centigrade increase in temperature over the last 200 years. And the strongest rise has really been since about 1980. So since about 1980, we've had this long and very continuous rise in temperature in New England. And this rise in temperature in New England and throughout the world, in every area of the world, is caused by well, first of all, to say that there is a very large increase in temperature measured throughout the world. So there are hundreds of weather stations throughout the world, and there's absolutely no doubt, based on these hundreds of weather stations throughout the world, that the world's temperatures are rising, and also that rainfall patterns are changing. Generally, drier places are getting drier, and wet places like New England are getting wetter. And there's absolutely no doubt among scientists that the cause of this increase in temperature, this climate change, is caused by the increased levels of carbon dioxide in the atmosphere. So carbon dioxide in the atmosphere traps heat close to the surface. So light passes through carbon dioxide in the atmosphere, but as light hits the ground, turns into heat, and then radiates back into space, carbon dioxide traps the heat near the Earth's surface. And the more carbon dioxide in the atmosphere, then the more heat tends to get trapped close to the surface, just like blankets. Just the same way if you go to sleep at night and you have normally sleep with 2 blankets and you're comfortable, and if you put on a 3rd blanket, then you wake up in the middle of the night and you feel hot. And if you put on a 4th blanket at night, then you wake up at night feeling like you're burning. And the world needs carbon dioxide in the atmosphere, because without carbon dioxide, the world will be too cold. And 200 years ago, there was about 270 parts per million of carbon dioxide in the atmosphere. And because of all of our burning of fossil fuels like oil, coal, and natural gas, and burning of tropical forests, tropical rainforests, there's now more than 400 parts of carbon dioxide per million in the atmosphere. And that number is going up by about 2 or 3 parts per million every year. So the world keeps getting warmer because we keep putting more carbon dioxide and methane and other gases into the atmosphere. So there are some people who are very skeptical of the idea of climate change, but it's really something which is completely accepted by scientists and completely proven. The thing which is really should be up for discussion, which we should be debating, is how are we going to deal with that problem? Are we going to try to reduce the levels of carbon dioxide in the atmosphere to deal with the problem? Or are we going to build seawalls around our cities to protect them from rising sea levels? Are we going to have more air conditioning in our house to keep the houses cooler? So really the question is, what should we be doing about climate change, and how should we be spending our money to deal with the problem? But the reality of climate change is certainly there. Anyway, so you can see that the climate is getting warmer throughout the world, including, for example, in Falmouth. And climate change has really serious consequences throughout the world. So this is a map of the world showing the impact of climate change on world agriculture. And all the areas shown in red are places where the agricultural yield will decline by 20% or more, often even by more than 50%, because the climate will just get too dry and too hot for agriculture. And so you can see that huge areas of Brazil, Africa, Southeast Asia, Southern Asia, areas of China, are all going to get too hot for agriculture, too hot and dry. And this is going to be a catastrophe for world civilization. So climate change sounds a little bit nice when you're in New England. I mean, a little bit milder winter, earlier spring, but in fact, it has dire consequences for the world's agriculture and the world's economy. And it has huge consequences also for low-lying coastal areas. So this is a map of Boston, and you can see that this is Beacon Hill right here. This is Kenmore Square where I work. The star right here shows where Boston University is. And all this area is Back Bay and Kenmore Square and South Boston and areas of Boston, a lot of areas where there's financial activity, residential neighborhoods. The airport is right here. The airport is right here. And you can see that this area is all going to get flooded by rising sea levels in the future. So this is a map showing what Boston will look like if it gets hit by a hurricane at high tide about 50 years from now, when the sea levels are about 1 to 3 feet higher than they are now. So most of Boston will be underwater in the same way that New Orleans was underwater after it was hit by Hurricane Katrina. And so many cities around the world, like New York City, Miami, New Orleans, are all very vulnerable to higher sea levels. And what does Cape Cod look like? And if you look at Cape Cod is actually one of the most vulnerable areas in the United States to rising sea levels. And it's estimated that if the world's glaciers continue to melt, and if the polar ice caps continue to melt, that by about 2070, the sea levels could be anywhere from 2 to 6 feet higher than they are right now. And this is a map showing what will happen on Cape Cod if the sea levels get about 1 foot higher than they are right now. And you can see that all these areas shown in pink are areas which will be prone to flooding with this higher sea level. And so you can see that there are enormous areas around Falmouth, areas on the southern part of the Cape, areas in the northern part of the Cape, and then also on the outer Cape. All these areas shown in pink are places which will be continuously flooded in coming decades. So not very far within your lifetime, these areas which are currently major town areas, areas where there's real estate, residential real estate, roads, infrastructure, electrical infrastructure, are all going to be underwater unless massive seawalls are built. And even the seawalls might not be able to protect them. What's also very interesting about this map is that you can see that there are these places, various places on the outer Cape, where there are low-lying areas and areas which are prone to flooding. And these are areas which, if they are hit by a major hurricane, like Hurricane Sandy, for example, during a time of high tide, that the sea will break through these areas, and these areas will no longer become passable by roads and vehicles. And so there will be this tendency for the outer Cape to break out into a series of, or break up into a series of islands sometime within this century, which is a very, very frightening possibility. It's really going to alter the whole economy and ability of people to move around in Cape Cod. Also pointing out that the tip of Cape Cod, so all this area around Provincetown, is one of the most vulnerable areas, and it's very unlikely that this area will even continue 100 years from now. It will all be underwater, as well as perhaps even being an island. So you can see that even this area around Falmouth here is extremely vulnerable to higher sea levels. So climate change isn't something just kind of funny and interesting. It's not a funny, interesting scientific topic. It actually has very dramatic economic consequences for a place like Falmouth. Just kind of one example of a physical characteristic besides temperature is that the effects of rising temperatures on the time in which ice melts in the spring. So Walden Pond is a very well documented pond, and at Walden Pond, the pond always used to thaw at the end of March or the beginning of April, and now Walden Pond thaws in the middle of March or early March. And so it's just kind of an example of how climate change, the air temperature, is affecting things on the ground. So I'm a biologist, I'm a plant ecologist, and what I'm interested in is how the diversity of life will be affected by climate change. And the second question that our research group is interested in is, why should we care about it? Well, we should care about how climate change is affecting biodiversity because we are concerned with the protection of rare and endangered species, but also we're concerned with forests because that winds up creating clean water for us. We're concerned also about getting timber from the forests, but also that biodiversity is something which provides us with a lot of beauty, which gives us a lot of products which we use, and also enriches our lives. And it's also an indicator of other things. So for example, if we see the effects of climate change on plants and animals, climate change will also affect us from the perspective of things like heat waves, outbreaks of disease. And the third question that our research group was interested in is, what are we going to do about it? So if we see that climate change is a reality and it's affecting the world around us, what are we going to do about it? Are we just going to sit there and just be very passive? Or are we going to try to change society, change the reality of climate change to make it so that it's not as severe in terms of its consequences? So as biologists, we're looking for indicators of climate change. And the key indicators that we have of climate change are, first of all, the timing of events, particularly in the spring, what scientists call phenology. The second indicator is the distribution of species. So particularly birds and butterflies can move around depending on the temperature. And then the third indicator is the abundance of species. So some species like warmer temperatures and they do better. And then other species like polar bears, for example, they don't like warm temperatures and they won't do as well if the climate gets warmer. So these are all three indicators that we can use to look for the fingerprints of climate change. And the key approach that biologists have developed for looking for climate change is to find old records and to match old records against what's happening today. And as I've mentioned, a lot of my research in the past was in Southeast Asia, but also in East Asia, in Japan and Korea. And in Japan and Korea, it turns out they have fantastic old records. They have some of the oldest records in the world about when things were happening in the past. And in Japan and in Korea, people really enjoy watching cherry blossoms in the spring, just the same way we had cherry blossoms in the United States a few weeks ago. And in Korea, shown on the left here, people have just been celebrating the cherry blossom festivals for more than 130 years. And this year in Seoul, Korea, they had the earliest cherry blossom festival ever recorded in Korea. That because the cherry trees are very sensitive to temperature and they start flowering earlier in warm years than in cold years, they had a very warm spring and then the earliest cherry blossom festival ever. Japan has even earlier records. So this picture from the right is showing the cherry blossom trees flowering in Tokyo. And in Japan, they have records of the cherry blossom festival going back to the 9th century. So they have more than 1,200 years of the celebration of the cherry blossom festival in Japan. And this last spring, the spring of 2021, is the earliest cherry blossom festival ever recorded in Japan. So they had this extraordinarily warm weather, and the cherry trees responded to that by flowering extremely early. In the United States, we've been searching for records for more than 20 years for this climate change research. And of all the records that we found, the best records in terms of being very old and very complete with a lot of species over many years were records kept by Henry David Thoreau. And I'm guessing your teachers have told you about Thoreau. So Henry David Thoreau was a very famous environmental philosopher who lived in the 1840s and 1850s in Concord, Massachusetts. His most famous book is Walden. And in this book, Walden, Thoreau describes the need to fight against things like war, fight against slavery and prejudice, but also the need to live simply. And Thoreau, during the 1850s, Thoreau made very detailed observations of when plants were flowering and trees were leafing out and birds were migrating in Concord. And we've been using these to look for the effects of climate change. So this is a picture of Thoreau's records. So his writing is in blue here. Excuse me, his writing is in black. So he's writing the names of plants in black. And then also he has numbers here. These indicate the days of the year that he first saw plants in flower. And this is one of his tables from May of 1857. So his writing is in black, my writing is in blue. Thoreau had notoriously bad handwriting, but this one, like here, is high blueberry. So this stands for the high blueberry bush. He first saw it on May 14th, 1857 in Concord. This is a picture of this plant. And so what my students and I have been going out, what my students and I have been doing since 2004 is going out into Concord and making the same observations. And I can tell you, the highbush blueberry, which he first saw flowering in the middle of May during the 1850s in Concord, we now see much earlier. So it's already flowered this year. It's already started to flower this year, even though it's still the month of April. And so what we've been doing is we've been going out and looking at the flowering times of plants in Concord, matching them with the records of Henry David Thoreau. And we also found that there was another botanist in Concord named Alfred Hosmer, and Hosmer also observed the flowering times of plants in Concord. So my students and I would go out every spring and we would record when is the first day that we can see an open flower of the lady sleeper orchid in Concord or the bird's foot violet. And then we would match these observations with the observations of Thoreau and Hosmer. And this is a picture of the kinds of stuff that we found. So if you look at this figure right here, on the x-axis here, we have the dates in over time. So from the 1850s, through 1900, and then up to the present time right here. And on the y-axis right here, we have the dates in the spring that the plants are in flower. And each one of these symbols here represents a year of observations made by Thoreau. So you can see there are these 6 years of observations of Thoreau. And then we have these observations made by Hosmer. Each one of these green triangles is a year of observations. And then we have our observations shown as these red circles right here. And what you can see is there's a lot of variation, but on average, in Thoreau's years, the plants were flowering around May 15th. In Hosmer's years, the plants were flowering around May 10th. And in our years, the plants were flowering around May 5th. So even though if you go out to Concord today, and Concord still looks like a beautiful, picture-perfect New England town, that the plants in Concord are now flowering about 10 days earlier than they were during Thoreau's time. And so we can see that there's this shift in flowering, which is probably related to climate change. And the reason that we know it's climate change is if instead of looking at changes over time, we look at changes in relationship to temperature. So each one of these dots here represents a year of observations. And on the x-axis here, this is the average spring temperature in March, April, and May, expressed as degrees centigrade. So these are cold springs, and these are very warm springs. This year is actually a very warm spring in Concord, Massachusetts. So these green dots here, these red dots here, these are our observations, and you can see they're basically very warm. Thoreau's observations are shown in blue. His years of observation are in blue, and these are very cold springs, so he lived in a colder time. And these orange dots are Hosmer's observations, which are more kind of intermediate. And what you can see here is that when it's a very warm, when it's a very cold spring in Thoreau's years, the plants tended to flower late. And in these red dots, our years, the plants flower, which are very warm years, the plants flower very early. And these years of 2010 and 2012 were extremely warm springs. And in those years, the plants really had record early flowering time. So you can see that the plants are flowering earlier now than in Thoreau's time, and they're flowering earlier because it's warmer, and it's warmer because of climate change. So what about leafing out times? So Thoreau also looked at the leafing out times of trees like oak trees, maple trees, ash trees. And we know also that trees and shrubs are now leafing out earlier now than in Thoreau's times, but that the trees are not as responsive to the wildflower. Excuse me, the trees are more responsive than the wildflowers to climate change. So the trees, the plants have, the wildflowers are now flowering about 10 days earlier than they did in the past, but the trees are leafing out about 14 days earlier. So they're more responsive to climate change than the wildflowers. Now, when we look at the leafing out times of trees, we find that there are other good resources that we can draw on. And besides the observations made by people like Thoreau and Hosmer, New England is also extremely rich in collections of photographs. And at many botanical gardens, there are collections of plants and flower, but we came across a woman who had a collection of photographs taken at historically important cemeteries on Memorial Day. So this woman had an enormous collection of photographs taken at cemeteries on May 30th at different places. And she had one photograph that she said was really unusual. Now, if you look at this photograph here, it was taken on May 30th, 1868 at the Lowell Cemetery, which is a city north of Boston. And there's something really strange about this photograph for May 30th. And the reason this is a really strange photograph is that the trees don't have any leaves. And this photograph on the right is a picture taken as close as I could get to being the same angle taken on May 30th, 2005. And you can see that the trees, as expected, are fully leafed out. And in the 1860s, the temperature was just much colder than it is right now. And when you look at weather records from 1868, you find that there were temperatures below freezing in March, April, May, and even into June. So astonishingly cold weather, and even freezing temperatures, hard freezing temperatures, even into May. So either the trees never leafed out by May 30th, or they'd started to leaf out and the leaves were killed by freezing temperature. So our research group is also interested in looking at the effects of climate change on birds. And we want to find out if birds are responding to climate change, and is their response similar to plants. And probably the best weather record, the best birding records anywhere in the New England region is at the Manomet Bird Observatory, just near Plymouth, not so far from Falmouth. And they've been trapping birds there since 1980 in the spring. And we've looked at their weather records, and we find that the birds, some bird species are responding to climate change a little bit, and then a lot of the bird species, particularly the ones that are coming from South America, that are migrating all the way from there, they are not responding to climate change at all. So birds, some birds are responding to climate change, but it's a much less strong response than we find for plants. And if we show this graphically, if we look at the spring temperature, like cold springs and warm springs, and when particular groups of species arrive in the spring, what we find is that by the steepness of the line here, the steepness of the slope, it gives us an indication of how responsive species are to climate change. And what you can see here is that the first leafing out date of trees is very responsive to temperature. So trees are responding very strongly to climate change. The first flowering date of wildflowers is kind of intermediate, not as steep as the trees, but that birds really have only the slightest response to climate change. And therefore, there's the possibility that if these groups of species are responding differently to climate change, they might come out of ecological sync with one another, and that maybe birds won't be able to find enough food to really sustain them in the spring when they arrive here from their tropical locations. And the missing link in this story are the insects. So when the birds arrive in the spring, they're mostly feeding on insects. And when the insects emerge in the spring, they're mostly feeding on flowers or other parts of plants. And we really had a lot of trouble finding good data about insects, but we now are starting to get good information about the effects of climate change on insects. And we find that they're very responsive to climate change in a way which is similar to wildflowers. Also, when we've been doing our studies of climate change, we find that a lot of wildflower species that we're searching for to find out their flowering time, that we can't find them anymore. And so we're also finding that climate change is affecting the wildflowers of New England. And about 27% of the wildflower species which were present in our forests 100 years ago, we can't find anymore. And we know that a lot of this change in wildflower populations is due to climate change, because a lot of the wildflower species that are northern cold-loving wildflower species are the ones which are declining and going extinct. And this is also true for birds and butterflies. So we find that a lot of southern species of birds and butterflies are extending their range further north in New England as the climate warms. And a lot of the cold-loving birds that we have in this region are gradually declining and moving further north. So most of what I've been telling you about climate change is about what's happening in the spring. That's actually the season which is the most well studied in terms of climate change, but there are also other effects. So for example, climate change is affecting things happening in the autumn. So trees often keep their leaves longer in the autumn now than in the past, and birds stay around a lot longer in the autumn than they did in the past. The summers are hotter now than they were in the past. We have heat waves now in ways which we didn't have. And then we also are having mild, snowless winters, and this is affecting the ecology of the trees as well. I mean, our group is particularly interested in studying what happens to birds if they stay longer in the autumn, how will they find food to eat? And so this is a focus of our research group. One thing which I also really want to mention now in conclusion, as I'm getting near the end of my talk, is that I've been telling you about the effects of climate change which have already occurred in this region that we've discovered. But the climate of New England will continue to change over coming decades and within your lifetime. So this is a projection here of what the future climate will be like of the world and of New England. And the projection was, up until about 5 years ago, was that we were probably going to stabilize at increasing about 2 degrees centigrade or about 4 degrees Fahrenheit in temperature by the end of the century. But because the United States and China couldn't come to any agreement about dealing with the problem of climate change, we're probably closer on track to about a 3 degrees centigrade or about a 6 degree Fahrenheit increase in temperature by the end of the century. So what does this mean for the climate of New England, the climate of Massachusetts, the climate of Cape Cod? Well, this is the climate of, when I was growing up, Massachusetts had a climate like Massachusetts. But right now, Massachusetts has a climate like New Jersey did when I was growing up. And by the end of the century, the climate of Massachusetts will be like the climate of North Carolina. So the climate of Massachusetts continues to get warmer, and it is more like the climate of southern states. It will be more like the climate of southern states by the end of the century. So this is very serious. I mean, it's a very serious consequences for the people of this region and for the economy, for the forests, for the fisheries of this region, for all of our habits and hobbies. But it also means huge consequences for the plants and animals of this region. So for example, the Venus flytrap is one of the most amazing plants in the world. It only occurs on the coastal plain of North Carolina. And by the end of the century, it's going to be too hot and too dry for the Venus flytrap on the coast of North Carolina. And the place where it's going to be really good for it to grow in the United States is going to be actually on the coastal plain of Massachusetts, probably in places like Cape Cod and around Falmouth. So it's going to be very difficult to protect a lot of the species which are currently rare and endangered on Cape Cod, because the climate's going to change. But on the other hand, Cape Cod will probably emerge as an important destination for a lot of the rare coastal plain species which currently occur far to the south of New England. So this is my take on climate change and the science of climate change. But I think that scientists have an obligation, and people, and including students like you, have an obligation to learn about climate change and to tell people about the reality of climate change. And so what I do in my life is I talk to journalists and I tell people about climate change. I talk to groups of children and groups of students about climate change and tell them about the reality and the things that people can do about it. And so this is something that all of you can do too. You can learn about climate change in your schools. You can talk with people in town about it. Climate change is a reality in places like Falmouth, and there are things that you can do about it. So one of the things that people can do is to make observations. So I go out and I observe birds, I observe what climate change is doing to agricultural crops. So for example, this was during a drought, the agricultural crops just dried out and died in the fields. When we have unusual droughts, for example, and heat waves, we can see that the trees change color earlier in the summer and lose their leaves in the summer. And again, this is something that you can do. You can make observations yourself. As individuals, you can keep a journal, or you can participate in citizen science activities. So there are a number of citizen science websites, like one is called eBird, another one is called the National Phenology Network, another one is called iNaturalist, which helps you to identify things. And you can use these smartphone apps, and you can contribute observations which can help you to observe climate change, but also you can contribute to these larger scientific efforts. And in places like Falmouth, there's really a lot to observe. So climate change is going to be having dramatic effects in places like Falmouth. So for example, coastal flooding is going to become more frequent in Falmouth in the future as the sea continues to rise up, and then it will overtop the coastal seawalls and come into town areas. You can also keep records of temperature in your area of the land and also of the ocean. And you will see that over time that the temperature of the land and the sea gets warmer. You can record when ponds freeze in the autumn and when they melt in the spring. And if you have good equipment, you could measure ocean acidity. The ocean is getting more acidic over time because of increased levels of carbon dioxide in the water. If you're interested in birds, you could record when birds first arrive in the spring. You could record when plants are flowering and leafing out around your home or in your neighborhoods. Since Falmouth is on the coast, if those of you interested in fish, you could be recording like what kinds of fish people are catching, what kinds of invertebrates people are seeing, how much lobsters people catch, how much shrimp they catch in your area. So these are all things that you can do. And for those of you, you're in the 8th grade, I'm guessing you're like 12 and 13, 14, sound about right? So, you know, you have a great opportunity to start keeping observations now, journals right now, recording both yourself and with your families, like when the apple tree flowers in your yard, when the daffodils flower in your yard, when you see the first hummingbird at your hummingbird feeder. So if you start recording things like that, you will see changes over the course of the next few decades. And this represents a real opportunity for you. So in my case, I always keep connecting back to Thoreau. So I'm not sure if you've read the book Walden yet. I'm guessing you might not have read it yet, but you'll probably read parts of it. And certainly when you're in high school, if and when you go to college, university, you will read the book Walden. And the book Walden, it has a number of simple messages to it. So one is to observe nature carefully. So Thoreau goes out and he lives by Walden Pond in a cabin for 2 years, and he teaches us the value of observing nature. And if you observe nature carefully in Falmouth and around your homes, you will see the effects of climate change within a few years. You will see how things are changing. Another one of his lessons of the book Walden is to live simply. And he argued that we should live simply because if we live simply, we'll be happier, we will be healthier, and we won't have to work as hard because we will be satisfied with the simple things in life. And that's really how we need to deal with climate change. The reason that we are having this problem with climate change is because we're burning too much oil, coal, and natural gas. As a society, as a civilization, we're just using too much of these fossil fuels. And we need to live more simply and to use more renewable sources of energy. And this will allow us to deal with the problem of climate change. And then the third message that I get out of the book Walden is the need to affect society. So Thoreau, throughout the book, he tells us we should stand up against injustices and authority which is acting incorrectly. So in Thoreau's life, there was slavery, and he spoke out very strongly against slavery. Of course, we still have the problem of racial injustice in the United States. He said we should stand up very strongly against war, and war is a great problem in the world today. So in Thoreau's time, it was the war against Mexico that he opposed, and we still have war in the United States, in the world today, and Thoreau would oppose this. But he would also tell us that we should stand up and urge the governments in our town, the state government, the national government, and the associations of countries to form agreements to deal with the problem of climate change. So we need to deal with the problem of climate change as individuals and to live more simply, but also we need to do that as a society. So in my case, I took all of the information which I'd learned from my study of Thoreau and climate change, and I put this in the book Walden Warming, which is my trying to reach people with the message of climate change. And with that, I stop, and thanks very much.
Forgot to unmute myself again. Thank you so much, Mr. Primack. Sorry, my bad. I knew I was going to mess that up. I do have some questions in the chat for you, which hopefully I can pull up since I just made them disappear. There we go. Okay, so our first question is, how do we adapt to climate change? And then the second part of that is, and how does it affect animals like deer or fish or frogs?
Well, how do we adapt to climate change? Well, I mean, how many hours do I have? So I think that the ways in which we adapt, I mean, there are these two things we can do. We can do things to try to reduce our emissions of carbon dioxide, and we do that by using more fuel efficient vehicles, like smaller vehicles, ones that have better gas mileage, or trying to use public transportation. We can better insulate our homes. We can try to shift to renewable energy like solar generated electricity. We can eat simpler foods, particularly eat less meat. But in places like Falmouth, climate change is going to happen. It's going to be a reality. And so you have to adapt to the reality of a warming climate and more frequent hurricanes and higher sea levels. And what will happen in places like Falmouth and what's happening throughout Cape Cod, what's happening throughout Nantucket and Martha's Vineyard, is that people are getting used to the idea of it's going to be impossible to protect homes that are built right near the ocean. They're either going to have to be moved farther back or they're just going to have to be demolished. And that certain roads won't be able to be maintained if they are too subject to flooding. They're just going to have to shift roads into more interior areas or just not maintain them. People will have to build seawalls. In many towns on Cape Cod, people have a lot of the infrastructure right at sea level, kind of in the town areas. A lot of the electrical generation equipment, a lot of the gas infrastructure, a lot of the loading facilities, and these are going to have to be shifted into more protected areas on higher ground. And so these are ways in which people are going to have to deal with this. If there are seawalls, the seawalls are going to have to be raised, because as the ocean gets higher, the seawalls have to be higher to protect those areas. So these are all things that people are going to have to do to adapt to climate change. Just as the one very specific thing is, we have hotter temperatures, people might have to install air conditioning in their homes because it's just going to be too unbearable without air conditioning.
So, and I know that we talked earlier about the geography of the Cape, but I did have a question. What about Falmouth and Mashpee is the most vulnerable? Is there higher elevation in lower Cape areas? So, what about Falmouth and Mashpee is most vulnerable? So I'm assuming that the areas will be like near the ocean. Oh my goodness, the areas nearest the ocean would be the most vulnerable. Yes.
Right. So I mean, on the map I showed, I mean, it shows the areas that are most vulnerable. I mean, the areas that are most vulnerable, the areas which are closest to sea level. And I mean, around Falmouth, I mean, all those areas on the western coast and the southern coast of Falmouth, they're all extremely vulnerable. So all these areas which are sort of low-lying areas around coastal ponds, around kind of marshes and bays. So all these homes that are just built like 1 or a couple of feet above sea level, in those areas, all the roads, those are really the most vulnerable areas. So, and that includes really, so much of Cape Cod. It's really only these hilly areas that are a little bit more protected. But even there, they're not completely protected. So people in those areas shouldn't think of themselves as being so safe, because I mean, a lot of the road network of Cape Cod is at sea level, and those road areas are going to be flooded and washed out during hurricanes. And so people won't be able to get around. And also a lot of the water supply of Cape Cod depends on aquifers. Freshwater aquifers are in the middle of the Cape. And those areas, when the sea surges in hurricanes, it's going to put salt water into those aquifers, and that's going to threaten the water supply of Cape Cod.
Okay, so I have another question that says, when did you first know that you needed to speak about climate change?
Well, I first became I first started thinking a lot about climate change when I shifted this focus of my research. So up until about 2002, I was giving a lot of talks about tropical rainforests. And I started to look around I started really quite deliberately decided to change my research focus around 2002 and 2003. And I mean, it was very exciting for me. So just seeing these research opportunities. So climate change is a great threat, and it's kind of frightening how serious a threat it is. But it's also very exciting scientifically because we see the world changing in front of us. So as a scientist, it represents a great opportunity. So I became very energized by this idea of studying climate change. My students got very excited by it. And then also when we discovered these old records of Thoreau, it represented a very good way to tell the story of climate change. And so as soon as we started working in Concord and then seeing how things were changing in Concord, that's when I started feeling like talking, and people started being very interested in what my students and I were doing.
I do have another question that I discussed with one of my students in class, and I promised that I'd ask. He wanted to know, what is it, or why do you like science so much?
Well, I was always interested in science. So I think that for me, it's always been, I've always had these passions to do things. I've always just become very enthusiastic about things. But certainly a continuity in my life is the fact that I've always been interested in science. And I was always just taking science courses, mostly biology courses, but science courses in general. It just seemed to be a very logical way of looking at the world and thinking about the world and understanding the world. I mean, it wasn't something that I just thought about. It was just something that I enjoyed and that I was good at. And I was basically drifting toward probably a career becoming a medical doctor when I signed up for this class just by chance in plant ecology. And I just discovered that I just had such an incredible passion for plants, that I just liked plants so much, and I wanted to be looking at plants and knowing their names and understanding how they grow. And this passion began when I was 20 years old, and it's actually never left me. So in all of that time, I continue to have this incredible desire to go out and look at plants. So actually, after this class is over, I will go out and I will be taking measurements on pine trees, and taking some measurements from an experiment that I've done. At various times in my life, I've tried to become interested in birds, and I've tried to become interested in butterflies, and it has not been successful. So I know a lot about birds, I know a lot about butterflies, but it's just not the same intensity that I really bring to the study of plants. So with me, it's just something which is it's very, very ingrained within me.
So another question is, why do you think there was barely anything about climate change in New England?
I mean, why hadn't people studied it earlier? I think that people just didn't know how to approach the subject. I mean, people were studying climate change, but they weren't studying they weren't studying the previous effects or how the climate had changed since earlier times. So people have developed different techniques for looking at climate change, and the approach that we started, no one had really tried doing it in the United States before. There were other approaches to studying climate change. So one very common approach that people have for studying climate change is by setting up climate change experiments. So people, for example, will put out heating coils in the ground, or they will have radiant heaters above the ground where they will try to warm the ground or try to warm a certain section of forest, just like the effects of climate change, just like global warming. So they will try to do experimental warming and seeing how that forest will respond. Or they'll do experiments where they will surround a forest by plastic and then pump in extra carbon dioxide to see how the plants respond to these raised levels of carbon dioxide. So there were these approaches that people had tried, but people just hadn't thought about using this kind of historical approach that our group had done.
This is a good question. Is there a way for climate change to be reversed once it's done?
Well, people are developing ways of trying to lower the amount of carbon dioxide in the atmosphere. And so, I mean, there's two approaches. One approach is that we should be producing less carbon dioxide. We should make great attempts to reduce the amount of carbon dioxide being produced every year. This method is very challenging because countries like India and China are still building coal-fired power plants and are still dramatically increasing their um, number of cars and trucks that people own. So, 30, 40 years ago, there were virtually no private cars in China, and now, every middle-class family in China wants to buy a car. And, why shouldn't they have a car? But the problem is that means that ever more fossil fuels being burned in countries like China and India. So it's very difficult to kind of stop this steady increase in the amount of dioxide in the atmosphere. The other possibility is by developing technology which actively withdraws carbon dioxide from the atmosphere and then buries the ground, deep in the ground. And this is a possibility. The problem is that this technology is extremely expensive right now. And unless we can make it cheaper, it doesn't seem to be a very viable method. Another possibility is to dramatically increase the amount of trees being planted throughout the world. And this is something which could also slow down the rate of carbon dioxide increase.
How long did it take you to write your book?
Well, it took quite a number of years because, as you may know, the book industry is just going through a lot of changes right now. So people aren't buying as many books, and they are often reading books online. So it's a very, very challenging effort. So the great challenge was actually to find a publisher. Once I found a publisher, it took about 2 years to write the book. But then I wrote it as a scientist, and the publisher wanted me to write it much more as a popular book. So I had to spend another year or two working with a professional editor to making it much more sort of a popular seeming book. So I started writing it I think in 2006, and it wasn't actually published, I think, until 2014. So it took about 8 years for it to be published, but probably only about 2 of those years were writing years.
What would the effects of 100 people planting 1 tree every day due to global warming?
Well, not much. I mean, I think that the problem of climate change is really just such an enormous problem that even though individuals need to do things, and even though individuals should take actions on their own, like planting trees or not eating meat or turning down the thermostat in the winter, that it really requires global solutions. So the single most effective way in which climate change will be dealt with is the United States and China having a very strong agreement to deal with climate change. Because if the United States, the world's wealthiest country, and China, the world's largest emitter of carbon dioxide, if these two countries can form an agreement and then bring the other countries of the world into that agreement, that's the way in which the problem will be dealt with. So probably the single most important thing that all of you can do and that your families can do is to write letters and talk to politicians and make your kind of opinions known to political leaders and get them to urge the United States government and the Chinese government to form an agreement. And I think the situation to do that right now is favorable because President Biden is bringing in these new policies into the government to deal with the problem of climate change. And so because of this kind of strong opinion of the new president, I think that we have this possibility of creating a strong agreement to deal with climate change.
Okay, and I think we have time for maybe 1 or 2 more questions. So I have a question that said, if all humans disappeared, would climate change still continue?
Climate change will still continue for many hundreds of years. And the reason for that is that Carbon dioxide and methane and other greenhouse gases are only withdrawn very slowly from the atmosphere. And we've raised the level of greenhouse gases so dramatically in the atmosphere that it will take hundreds of years for it to come back to pre-industrial levels. So the world will continue to warm regardless of whether people, disappear or stop producing carbon dioxide. It's just a question of how slowly it will take to return to normal levels, how long it will take, and how much damage will be done before the levels return to their original level.
Okay, will Antarctica eventually melt? I believe they mean completely.
That I'm not positive. So I'm not a kind of an atmospheric scientist. So I don't know if it's going to melt completely, but I think there's that possibility. So I mean, I think that the Antarctic and the Arctic did melt completely in the past, and I think that there's that possibility. If we continue to produce more carbon dioxide, there's the possibility of those areas completely melting and the sea levels rising by hundreds of feet. But that will take hundreds of years, and hopefully we will take some measures before that happens.
Okay, one last question I think is there an estimate for a year when it's going to be too late for humans to try and reverse what has been done?
Well, I think it's never going to be too late. It's just always a question of how much damage is going to be caused and how expensive it is to clean up the problem. I mean, the example I always think of is like fixing the leak in your roof. So if you have a leaky roof in your house and there's a little bit of a leak, and maybe you can, go up there and, you can just fix one shingle and, put a nail down and you fix the problem, and it's a small problem. But if you ignore it and you let the shingles keep deteriorating and shingles getting blown away, then there's more damage. And if you completely ignore it and water starts pouring through your house and ruins all the rooms of your house, then it's very difficult to fix and it's very expensive to fix. And it's the same thing with climate change, is that the longer we delay, the more difficult it is to fix and the more expensive it is to fix. But humans are very adaptable. And especially in a country like the United States, which is a very wealthy country, we will always have the ability to fix the problems in an expensive way. But for poorer countries of the world, so for example, countries like India, countries like South Africa, those countries don't have the ability to fix the problems. And then when climate change happens, it's going to be devastating for the people in those countries, and it's going to cause people to starve to death and die.
Keep forgetting to unmute myself. All right, ladies and gentlemen, so we are just about out of time with Mr. Primack. So thank you so much for speaking to our kids, speaking to all of our kids. It was very fantastic. I love the questions. I literally have 83 more questions, which we can't get to. So plenty of questions. So I believe you definitely got their attention.
Okay.
All right, so ladies and gentlemen, you are all set. If you did put a question in the chat, I will be saving the chat, so I will see it. Don't worry, I will make sure I see that you asked a question. All right, I'm going to unplug you from the main speaker. Hang on one sec. Yes. Okay. Okay. I'm just waiting for the attendee list to go down.
I see we have 99 comments in the chat, huh?
I have 121 messages below where I'm at right now. Mm-hmm. A lot of them are saying thank you, thank you, thank you, thank you, thank you, because the kids have learned obviously to say thank you at the end of presentations, but I have a lot of questions. A lot of questions.
Good group of kids, huh?
Yes, they are a fantastic group of kids, and they really do ask really good questions. Honestly, a lot of times they ask me questions about what we're studying that lead me to new things that I didn't learn either, and that I didn't know either, and it's really fantastic. So I'm also going to stop the recording.